What unfolds when humanity merges technology with biology? It's the transformative ability to rewrite the very essence of life. Imagine a future where organ farms flourish. Governments employ artificial wombs to boost populations, and robots integrate biological components. Today, we will discover how biotechnology will look like in 2050. So fasten your seatbelt and welcome to Inside the Future. Picture humans with genetically enhanced abilities, capable of healing through mere touch. Welcome to the realm of biotechnology. Yet, as we venture into engineering life, could we become a dominating species, disrupting our natural environment? Delve into the clandestine world of biohackers, operating away from the scrutiny of regulations. Consider the possibility. If we bioengineer human bodies extensively, might we evolve into an entirely new life form, transcending our current human state and verging on the alien? In this new era, humans won't just observe nature, we'll command it. The gateway to this evolutionary leap: bioprinting. Imagine a world where 3D or 4D printing transcends traditional materials like plastic or metal, utilizing living cells or bioinks. These cells, layered meticulously, can develop and intertwine, forming viable biological structures. Bioprinting doesn't just create, it imbues creations with life. It's the modern realization of the alchemist's dream. On a fundamental level, bioprinting has applications like creating corneas, hair follicles to tackle baldness, customized cosmetics testing, and healing combat wounds. Looking ahead, advanced bioprinting could fabricate 3D coral reefs, aiding marine life and repairing damaged ecosystems, or even miniature robot-operated space stations that serve as bioprinting hubs, exploiting microgravity for more efficient printing. In human health, bioprinting revolutionizes organ transplantation. Organ farms could alleviate donor shortages, while patient-specific cells could generate miniature organs or organoids for personalized medical testing. As we progress further into biotechnology, the line between biological and artificial becomes increasingly blurred. Bioprinted prosthetic limbs, meticulously tailored to individuals, use living tissue to enhance integration with the user's body. In cybernetics, electronic components are embedded in bioprinted structures, resulting in cybernetic organs surpassing their natural counterparts. Picture bioprinted lungs equipped with sensors and nanofilters, purifying air before it reaches the bloodstream, or bionic eyes with capabilities like zoom and infrared vision. These advancements, however, come with unforeseen consequences. Patients receiving experimental bionic eyes report experiencing what they describe as paranormal visions. Consider a former archaeologist who, after an accident that cost him his sight, receives a bionic cornea transplant. His restored vision brings with it hallucinations, leading him to believe he's uncovering ancient secrets that could alter history. Meanwhile, in a distant part of the world, a mysterious flesh-eating disease devastates communities. A team of scientists responds by using bioprinting to develop a new skin type resistant to the disease. This breakthrough sparks a debate. While some laud the scientists for their life-saving innovation, others are left pondering the implications of humans possessing a fundamentally different skin type. Shifting our focus to the more foundational aspects of biotechnology, we encounter the fascinating concept of living architecture. In this innovative approach, buildings are crafted using bioengineered materials capable of self-repair, air purification, pollutant absorption, and even self-reproduction. These structures incorporate cutting-edge technologies, such as adhesives inspired by gecko feet and eco-friendly concrete resembling coral reefs. Additionally, some of these futuristic buildings are energized by biological batteries, harnessing bacteria to store and produce energy. However, this advancement isn't without its controversies. There are growing concerns over forced obsolescence, with allegations that some companies are engineering their biomaterials to degrade after a predetermined time, compelling consumers to buy replacements repeatedly. In the luxury bio-apartments perched high in these buildings, bio-art forms an integral part of the decor. Artists are harnessing living tissues and bioprinting technology to create dynamic, evolving art pieces. In coastal cities, these bio-apartments are safeguarded against rising sea levels and storm surges by living seawalls. These structures are constructed using genetically engineered corals and mussels, creating barriers that can grow and self-repair, thereby fortifying the cities. Then, there's the enchanting innovation of bioluminescent lighting. By engineering plants, bacteria and algae to emit light, much like deep-sea organisms, these biological illuminations offer an eco-friendly alternative to traditional electric street lighting. In a quaint town illuminated by bioluminescent lamps that purify the air, an unforeseen withering of these living lights plunges the streets into darkness. Botanists and engineers are tasked with unraveling the mystery behind the dying neon blooms to rekindle the town's luminescence. Amidst this, conspiracy theories emerge, suggesting that the lights have been maliciously biohacked to emit harmful pollutants. In a different development, a robotics firm has created a robot cloaked in bioluminescent skin, glowing subtly as it guides visitors through museum exhibits. This innovation prompts public curiosity about the possibility of bioluminescent human skin. Meanwhile, underground biohackers are already experimenting with their own bodies, embedding microchips and using digital inks for dynamic tattoos that reflect their online presence. These cyberpunks, operating beyond the reach of government oversight, are crafting biocomputers from biomaterials and living neural tissue. They push the boundaries of brain chip technology, bypassing safety protocols for heightened neural experiences, and even use their DNA as high-capacity data storage devices. Beneath city streets, a black market thrives with novel bioengineered products. Biohackers design grapes that rapidly ferment into wine, create pest-resistant and allergy-free unregulated foods, and generate buzz with self-replenishing food containers, living entities that endlessly regenerate microfoods. These biohackers, dubbed cryonic punks, experiment with human cryopreservation, hoping for future revival. They even own genetically edited pets that exhibit bioluminescence, resembling glowing companions. Whispers of chimeras circulate, creatures born from a blend of genes from multiple species, reminiscent of the mythical Greek chimera. In a future where bioprinted prosthetic limbs seamlessly connect to the human nervous system, individuals regain not just mobility, but also tactile sensation and more intuitive control. This advancement leads to military programs encouraging voluntary amputations, aiming to develop super soldiers. A young boy, once paralyzed, finds new hope as he learns to walk using a bioskeleton. Each of these advanced prosthetics and exoskeletons is equipped with a unique registration and tracking number, monitored by governmental authorities. In specialized laboratories, scientists push the boundaries of reproductive technology with advanced artificial wombs, or ectogenesis pods. These devices offer a solution to declining fertility rates, with wealthy individuals and governments alike utilizing womb farms to outsource childbirth. Amidst this, rumors swirl about a dictator exploiting this technology to sire countless progeny, seeking eternal rule. Artificial wombs also find applications in space colonization, military enhancement, and reviving endangered species. Some researchers are delving into extended gestation, keeping a body in an artificial womb longer to potentially boost cognitive and physical abilities. The burgeoning industry of biohybrid robotics represents a multi-trillion-dollar frontier. These robots, integrated with biological tissues, offer superior flexibility and energy efficiency. One corporation is at the forefront, creating biomimetic robots that can camouflage and interact within natural environments, ostensibly for environmental monitoring and biological research. However, there's growing apprehension that these biorobots might become invasive species, inadvertently disrupting ecosystems and threatening native wildlife. Concerns extend beyond the ecological impact of biohybrid robots. There are fears about their potential use in espionage. Imagine drones or robots so perfectly mimicking birds that even other birds are deceived, machines capable of breaching national sovereignties. Governments might deploy these biohybrid creatures for covert operations, undermining the autonomy of other nations. In a scenario where a catastrophic biowaste disaster occurs, biohybrid robots, impervious to radiation, emerge as humanity's best hope. They are tasked with scavenging resources, rescuing survivors, and cleaning up hazardous waste. One pioneering biorobot even takes on the role of reviving extinct species, carrying DNA to rebirth lost animals. Then there are the neo-humans, real-life counterparts to comic book mutants. These individuals, primarily biohackers, have transcended conventional human boundaries to become a new species. For instance, a lucky individual in the biolottery becomes a human insect repellent, thanks to an engineered virus altering his skin cells and sweat glands to produce insect-repelling pheromones. A singer's vocal cords and resonating chambers are bioengineered to achieve an otherworldly range of sounds, transforming her into a living musical instrument. Another biohacker becomes a living canvas with biofabricated skin pigments that shift in reaction to light, temperature, and emotions, displaying dynamic art. The realm of biotechnology extends to even more remarkable modifications. Individuals are now enhancing their bodies with gill-like structures for underwater breathing. There's a modern-day Wolverine, fortified against bone fractures through bioengineered collagen and capable of rapid tissue regeneration, thanks to human tissues modified with reptilian healing properties. In the quest to reverse aging, people are experimenting with their telomeres and cell regeneration processes. Meanwhile, an individual claims to have achieved multitasking like never before, splitting their consciousness through organic brain enhancements. A breakthrough in healing comes from a person who, through touch, can transfer regenerative cells to others, demonstrating a profound level of biotechnological advancement. Biotechnology has become the intersection where nature's blueprint is reimagined through human ingenuity, a testament to the extraordinary next phase in humanity's evolution. Are you ready to harness the potential of ChatGPT for your enterprise? Mastering ChatGPT, from beginner to advanced, is your comprehensive guide, crafted by Corbin Brown, a seasoned account manager at WebCafe AI with a passion for transforming businesses through automation and AI. By enrolling today, you unlock a treasure trove of resources, 11 preset AI flows ready for your Zapier account, and 7 detailed PTFs to perfect your command of ChatGPT. With Corbin's expert guidance, shared through his years of experience, join a growing community of over 5,000 students who've elevated their businesses with AI. They also offer a no questions asked, 30 days money-back guarantee in case you don't like this course. Don't let manual tasks slow down your progress. Scale your operations and boost your efficiency. Click the link in the pinned comment below to start mastering ChatGPT and Zapier. Mastering ChatGPT, from beginner to advanced, where your AI journey leaps forward. Enroll now. If you like this content, don't forget to like and share this video and subscribe to our channel for more exciting updates on the tech world. This is Inside the Future.